Hello and welcome. If you're gearing up for a Java technical interview, you have come to exactly the right place. Think of this as your ultimate high-speed refresher on the most common questions that are going to get you hired.
Look, we all know that landing a great software engineering role often means proving you know Java inside and out. It's the language that powers the enterprise world, and interviewers expect you to be sharp. So let's get you ready for that challenge.
So here's our game plan. We'll start with why Java is so dominant. Then we'll nail down the absolute fundamentals. From there, we'll dive into object-oriented principles, memory management, and finally, how Java handles real-world problems. It's basically the perfect roadmap for interview success.
So why is there so much focus on Java? Well, it's pretty simple, actually. Almost every major enterprise application is built using it. Its reputation for being robust, secure, and portable makes it the go-to choice for massive systems, which means Java skills are always in high demand.
All right, let's get right into the fundamentals. These are the kinds of questions you can almost guarantee you're going to be asked, so let's make sure you have the perfect answers locked and loaded.
At its very heart, Java is designed to be straightforward and incredibly powerful. The key feature that interviewers really love is its platform independence. That whole write once, run anywhere idea means your compiled Java code can run on any machine that has a Java virtual machine, no recompiling needed.
Ah, here it is, the classic trick question. It seems so simple, right? But your answer reveals a whole lot about how deeply you actually understand the language's design.
And the answer is no, it's not, and for two main reasons. First, Java supports primitive types like int and char, which, are not objects. Second, the static keyword lets methods and variables belong to the class itself, not to an object instance. Nailing this answer shows an interviewer you get the practical trade-offs Java's designers made between pure theory and real-world performance.
So how does your code actually come to life? Well, first, the Java Development Kit, or JDK, compiles your source file into this thing called platform-independent bytecode. Then, the Java Runtime Environment, the JRE, uses the Java Virtual Machine, the JVM, to interpret and run that bytecode on any machine. That right there is the magic behind Run Anywhere.
Okay, now that we've got the fundamentals down, let's look at the tools you'll be using every single day, the core building blocks of object-oriented programming in Java.
This is another one you can almost bet on. An abstract class is kind of like a blueprint where some of the steps are already filled in. It can have both abstract methods you have to implement and regular methods that already have code. An interface, though, is a pure contract. It only defines what methods must exist. Knowing this shows you can think about code design, flexibility, and when to use a strict contract versus a partial implementation.
Just think of this as a way of saying my own. It refers to a variable or a method right here inside the current object. Super, on the other hand, is for reaching up to the parent class. You use it to access methods or constructors from the class you're extending.
The key difference here really boils down to ownership. A static method belongs to the class as a whole, kind of like a utility function. You don't need to create an object to call it. An instance method, however, belongs to a specific object. It operates on that object's data, so you've got to create an instance first. Okay, next up, let's dig into performance. How Java manages memory and data structures is a critical topic in any interview, mainly because inefficient code can bring a whole application to its knees.
I want you to imagine a huge library, but just for strings. When you create a string literal, Java first checks this string pool. If that exact string is already there, Java just gives you a reference to the existing one, instead of wasting memory creating a duplicate. It's a really brilliant optimization.
So when you use string literals, S1 and S2 are both pointing to that single ABC in the pool. But the moment you use the new keyword, you're explicitly telling Java to bypass the pool and create a brand new object on the heap every single time. Understanding this is absolutely crucial for any memory optimization questions.
Let's make this practical. For an online bookstore, you'd probably use an array list for your main catalog of books because order matters. For genres, a hash set is perfect because it automatically stops you from adding duplicates. And to quickly find all the books by a certain author, a hash map is ideal, linking a key, the author, to a value, their list of books. This brings us to another key memory concept. A shallow copy is like two people sharing one cupboard. If one person moves something, it affects the other. A deep copy, on the other hand, gives each person their very own piggy bank. Changes made to one have absolutely no effect on the other. Interviewers ask this to see if you're thinking about the potential for those weird, unintended side effects. Of course, programming isn't just about perfect scenarios, right? An interviewer wants to know if you can handle things when they go wrong, or when multiple tasks need to run at the same time.
Java has a really powerful way to handle this. You put risky code in a try block. If an error happens, the catch block executes to handle it gracefully. And then the finally block is for your cleanup code, like closing a file that absolutely must run whether an error happened or not.
When you're dealing with multiple tasks at once, you're dealing with threads. A thread starts in the new state, it becomes runnable when you start it, and running when it's actively doing work. It can become blocked if it's waiting on something, and eventually it becomes terminated once its job is all done.
Now this is an advanced but absolutely vital concept for multi-threading. Normally, for speed, a thread might read a variable from its own local cache. The problem? Another thread could have updated that variable in main memory, and the first thread would be working with stale, outdated information. The volatile keyword prevents this, forcing all reads and writes to go directly to main memory. Nailing this question shows you're thinking about those subtle but critical bugs that can pop up in concurrent apps.
All right, let's recap the highlights. Remember that Java isn't purely object-oriented because of primitives and static members. You have to master memory concepts like the string pool. Know your essential keywords cold, and be ready to clearly explain the differences between core OOP concepts. These are your tickets to a great interview.
We've covered the essentials, from the big picture all the way down to the specific keywords. You now have the blueprint for success. The only question left is, where are you going to start? Thanks for watching.